I know we have talked about this one in the beginning of the semester, all right? This is not new to you. But last time when we were doing this problem, this is the answer to the problem. We had this W is equal to nth input. So that we'll take that input and then convert it into an integer. And then we are going to use a if statement to determine if the weight is greater than 50. If it is greater than 50, then we'll decrease it by 1. And then we're going to print out the weight. So this is actually the answer that we provided last time. Today we are going to talk about another type of the statements. We call it the while statements. Okay. So last time we were talking, when we talked about the if statements, we have this syntax. So between this if and this column, we are going to have a conditional expression right here. And then we'll have a statement. And when this conditional expression is evaluated to true, then this statement will be executed. While this conditional expression is evaluated to false, these statements will be skipped without being executed. So this is actually the if statements that we were talking about. Today we are going to talk about another statement. We call it a while statement. And actually, if statement and while statement share exactly the same syntax. That means if we replace this if with the while, then the syntax is still okay. Like this. Let's try it. Maybe not this one. Okay. Let's run it. Run module. See, if we put 45, it will give you 45, like we have expected. But when we input something like 60, then it will decrease the weight by 1 and give you 59. Now, if we replace this if with a while, the whole program is still syntactically correct. That means you will be able to run it. However, let's see. If you input 60, then you'll get 50. That's amazing. Why? Because we only decrease it by 1. How can 60 become 50? To understand this, I'm going to show you another We call it a flow chart. Okay, here's a flow chart. This is the if statements, and this is the while statements. And the only difference about these two flow charts between these two flow charts is when this statement is executed. After this statement is executed, if statement will be exited, and the next statement will be executed. However, if you use while instead, then after this statement is executed, you will go back to the conditional statement. When it's true, this statement will be executed again, and then go back to the conditional expression. Then, if this is true again, it will be executed once more. However, this will keep going and going and going until this conditional expression will be evaluated to false, and then this while loop will be, and then we will terminate this while loop and then execute the next statement that follows. Alright, so we have this loop right here. It will keep going and going and going until this expression is evaluated to false. So this is what the while statement does. Since these statements will be repeated again and again and again until W is not greater than 50 anymore. So starting from 60 that we have input, it will decrease by 1 to 59. However, 59 is still greater than 50. So it will go back to the statement again and decrease it by 1 again. And W will become 58. And come back to the conditional expression again. And so the execution flow will run between these two lines and loop between these two lines until this conditional expression is evaluated to false. So it will be 60, 59, 58, etc. until like 51, and decrease it by 1, it will become 50, and then this will not be true anymore because 50 is not greater than 50. So this loop will be broken, and then the next statement will be executed. So 50 will be output to the screen. Alright, is there any question about
No.
how this while loop works? Any question? If not, please remember, when we have a while, the purpose of this while statement is to repeat the statements that follows. Alright? Okay, so this is actually not the answer to the problem provided. But we'll use it to solve this problem. The greatest common denominator, alright? However, before that, I will talk about this problem. the swapping of the two numbers, the swapping of the two variables. All right. We will input two values into x, y, and we are expected to exchange the value of these two variables and then print them out. Okay, like if we have 150 and 170 and 50, and then we will put 170 into x. We'll put we'll put 50 to y like this. X and y is equal to map int input dot split. Okay, and now we would like to exchange these two values. We put for the first test case, x will be 170, and then y will be 50, and then we would like to swap the values of x and y. Of course, this doesn't work this way. All right, it doesn't work this way. I'm just trying to show you something, and then we would like to print this. X is equal to x, then y is equal to y. We need to set the separator to, we need to disable this separator, made it to an empty string, so that it's not going to put a space between this x equal to and x, and it's not going to put another space between this equal sign and this y. Okay, so like this, we would like to output the x of 50, while when we input the value, the x is 170, but when we output it, it will be 50, like this. So basically, this is what the purpose of this problem. However, this problem is very stupid. I didn't make this problem. The textbook did. Alright, this is one of the exercises provided by the textbook. Let me show you. Where did I put it? I forgot where I put the textbook. There it is. It's on page, I forgot. Nah. Where is it? Where is the problem? I couldn't find it. Because there's a chart, there's a picture of it. I can't mix it. It should be easy to find. Should be. Alright, there it is. I'm sorry. It's 1.4 on page 22. Okay. See? This is actually from the textbook. Alright? Provided by the author of the textbook. And if we want to swap the value of x and y, can we do it this way? Can we do it this way? And the answer is no. You cannot do that. Like this. Let me try this. If x is equal to 170 and y is equal to 50. So if we want to exchange the values of these two variables, can we do that? X is equal to y and then y is equal to x. Can we do that? And the answer is no. Nobody wants to give me an answer, and I'm going to give you the answer. Okay? The answer is no. Why? Why? Why not? Be careful. When we have this x is equal to y, then x will be assigned a value of y. X will become 50. Alright. See, x is already 50 after this statement. Okay? And y is also 50 after this assignment. Both x and y will become 50 because we assign the value of y to the variable x. That means we want to set the value of x to the same value of y. So both x and the y are 50 right now. But if you do the next problem, it would be redundant because x is already 50 and x has lost the original value of 170. So you are actually assigned 50 to y, and y is already 50. And it will be the same. Y is still 50. And that's the reason why you shouldn't do this. So how are we going to do that? If we have x is equal to 170 and y is equal to 50, how do we exchange the values of these two variables? We need to save the value of x to the third variable first. The third variable of t will be assigned a value of x. In this case, t will have the value. T will keep the original value of x. Alright? So we can assign the value of y to x. And now you can see the value of x is 50. Alright? However, we want to change y into the value of into the original value of x, which is not in x, because x is already 50, and the original value of x is stored in the variable t, where we kept it first. in the variable t. Alright? So now we would like to assign the value of t to variable y. So this time y will be 170. So you can see that originally x is to 170 and y is equal to 50. And after these three statements, t is equal to x, x is equal to y, y is equal to t, then x holds the original value of y and y holds the original value of x, and the values of x and y are exchanged. So do you know how to do that? How to exchange the values of two variables? If you do understand, then let's go back to our code. How are we going to do this? Swap the values of x and y. We need to employ these three statements. T is equal to x, x is equal to y. Then y is equal to t. And then this will be the answer to the problem. Will be the answer to this problem. And the textbook is trying to demonstrate the process of these three statements using the cups and a picture of cups and waters. Alright, so it will make it a little bit more understandable, and you can try to understand it. However, this is in C. This is in C. In C++ or C. In Python, we don't need to do this. In Python, we can assign two variables at one time. Do you see that? We can assign the two variables from the input, two values from the input to two variables provided on the left-hand sides, respectively. Alright? So we don't need three statements. We only need one in Python. You can do this. X y is equal to y comma x. And this will be it. It is so easy in Python. Python can do this in just one statement, and these two values will be exchanged. I can show you again right here. Like x comma y is equal to y comma x. And then you will see x is changed back to 170 and y is changed back to 50. See? That works. So this is also the answer to the problem. Like I said earlier, this is a very stupid problem. I didn't make it. It was made by the author of the textbook. Why is it stupid? You don't even need to exchange them. The only thing you need to do is cheat, trying to lie to the system that s is equal to y and y is equal to x. And then on the screen, you will see the same results, exactly the same results. And then this problem will be solved. So that was hilarious. Yeah, this is stupid. This is stupid. You can solve this problem by lying. Without exchange these two variables, you simply lie to the system. X is equal to y, and y is equal to x. Alright? So That's why this problem is not a good one. However, I use this problem to show you how to exchange two values. So that we can move on to the next problem. The greatest common expression. The greatest common denominator. Alright? So, 激吸力 that stands for greatest common denominator. Alright? For this one, to solve this problem, we can have two approaches. The first approach, we call it enumeration. What is enumeration? That means try to list all the possibility and then check every possibility if that is the answer that we want. Alright? Alright, let's try this one first. The enumeration. Okay? And then I'm going to okay, we will input two values. And split up into two. I'm sorry, I'm wrong about it. We would like to map in inputs that splits like that. This should work. And then we want to get the greatest common denominator of A and B. And how are we going to get it? Like if we assume that greatest common denominator is the smaller one of A and B. Why? Because if you have two numbers, the greatest common denominator is not going to be greater than the smaller one of the two. Okay? It is not possible to be 15 because we have a smaller A of 12. Alright? So we start with the smaller value of A and B. However, this is not necessarily the greatest common denominator of A and B because we don't really know what A and B are. Like if A is 12 and B is 15, then A is not the greatest common denominator, which is of the two. Alright? So what do? We want to check first. Like this. While G while A is not divisible by G. Or B is not divisible by G. Either of this one happened, either of this one happened, G is not the common denominator. G is not a common denominator of A and B because it won't be able to divide A or B. What are we going to do when G is not a common denominator? We would like to reduce G by 1. For this one, if 12 is not the answer, then we will try 11 again. So G will be decreased by 1 from 12 to 11. However, 11 won't be able to divide 12. And you won't be able to divide 15 either. So this will be executed again to decrease the value of G to 10. And this one will keep going and going, and this statement will be repeated, and then G will be smaller and smaller one by one, and then smaller and smaller by one, and then until one day G is decreased to 3, and then we will find that this is false because G can divide A. 3. A is 12 when G is 3. 12 is divisible by G, and 15 is also divisible by G. And then both these two expressions will be evaluated to false when the two expressions connected by OR operator are both false. When these two are both false, then the OR will return false. And this while statement will be exited. Exited. And the next statement will be executed like this. So this will be the answer. However, this answer is not efficient enough to get 100 out of this problem. I'm not sure if I already put this answer right here. Alright, it's not. Let's try it. Let's save it and let's evaluate it. It will take quite a long time because, like I told you, this is not efficient enough. And you'll see you will be able to get only part of the scores instead of 100. You see, it's taking a long time. So you'll see. But is there a more efficient way to solve this problem so that we can get 100? Of course, yes. There's a algorithm There's an algorithm, and I forgot the name of it. Let me try to think of it. I forgot how to spell and how to pronounce the name of that mathematician. Is there an English one? I can't pronounce it. I don't know how to. Euclidean. Should be like that. Yep, this is it. Euclidean. Euclid is the name of that mathematician, and Euclidean is the algorithm, is what I'm trying to talk about. Euclidean algorithm. This is its Chinese version of it. Did anyone learn about this? Euclidean algorithm? Did you learn this? If not, I will try to. Let's go back. It should be done by now. Alright, yes, it is done. You get only 50. You get only 50 out of 100. Alright? And you'll get this program timeout error message. Program timeout. Okay? That means it's taking too long. The program is taking too long. And why is it taking too long? Let's get back to the description of the problem. See, the range of A and B, the largest possible value of A and B is 2 raised to the power of 31. That would be something like 2 trillion, more than 2.1 trillion, and that's a big number. Alright, so if the answer is 1, you need to decrease the G all the way to 1 before you can output the answer, and then it will take a very long time for a value this big, for a value as big as something like 2.1 trillion, and decrease it each time, decrease it by 1 each time, and all the way to 1. That will take a very, very long time. That's why the program is timeout, and then we get only 50 out of 100. Alright, so this process, we call it a enumeration, because we try to list all the integers. We try to list all the integers in from the biggest possibility, and then we decrease one by one. We list all the integers, and try to check if any one of them will be the answer. So we call this way of solving the problem enumeration. All right. And however, this is not efficient enough. Therefore, I would like to show you the Euclidean algorithm. Euclidean algorithm. Is there Euclidean? Well, let's try the Chinese version, see if, no. It doesn't really help a lot. Let's do it in Excel. For instance, if you try to see what is the greatest common denominator of 21 and 33, what do we do? First, all right, if this is the value of A, this is the value of B, all right? And first, we might want to divide, or maybe let's exchange it first. First, we would like to divide A by B. And what is the results of 33 divided by 21? The result will be 1, right? And what is the remainder? The remainder of this division will be like 12. Is that okay with you? And then we will change the value of A. We will change the value of A to 12. All right? And then we'll reverse the division. We will divide 21 by 12. Divide 21 by 12. Then the result is still 1, and the remainder will be 9. Is that okay? And then we'll reverse that again to divide 12 by 9. And the result is still 1, and then we'll get the remainder of 3. And then we'll reverse that again. We will divide 9 by 3, and the result will be 3, and the remainder will be 0. When either A or B is 0, the other one will be the greatest common denominator, will be the GCD of the two. Okay, so the GCD of 33 and 21 is 3. Do you see how that works? Do you see how that works? Anyone? Any question? And if not, then we'll try to solve this problem using the Euclidean algorithm. Map and input dot splits. Alright, and now we're going to have a while statement. And while B is not 0, while B is not 0, A will be A divided by B and take the remainder. Alright? Do you see that? A will be A divided by B and we'll take the remainder of 12. Not the quotient. We don't want the quotient of 1. We want the remainder 12. Alright? And this 12 will be the new value of A. So we'll take this 12 and save it back in A. And then A will be this 12. Alright? It will be changed from 33 to 12, like this one, from this process right here. However, just like you can shorten of this, like maybe like W is equal to W minus 1. You can shorthand it as W minus equal to 1. And these two are the same. You will get the same results. But this one is shorter and faster. Alright? It will run faster. Alright? And it's the same thing right here. You can also do the same thing right there. You can put this percentage sign right here, and then you can delete this. It will work the same way, but it will run faster. All right? Any question? And so the next step will be like we will divide 12. We will divide B, which is 21, by A, which is 12 by now. Okay? So we will have B is equal to A divided by B divided by A, and take the remainder of it. Alright? Until B is 0. When B is 0, A will be, when B is 0, and then A will be the answer. Alright? When B becomes 0, this will be evaluated to false, and then A is the answer. Let's try to run it. See if that is working. Run module. Alright, so this time we'll have this 33 and 21. And it's telling you 3. 3 is the greatest common denominator of 33 and 21. Are you guys excited? Are you guys happy about this? However, if you change the sequence, change the order of these two numbers by inputting 21 and 33. We get a 0 division error. Alright? We get a 0 division error. Alright? And why is that? Let's check the value of B. It's 3. And let's check the value of A. It's 0. You are actually divide 3 by 0. So that's a 0 division error right here. And B right here. B divided by A, when A is 0, it's not going to work. So how do we do that? This time we'll do something new. I will show you a new statement. if A is not if A is 0, if A is 0, then we will break the loop. We'll break the loop. Which loop? While loop. What does it mean to break a loop? It means it's not going to keep doing the following statements at all. When the break is executed, it will break out of the while loop, and then it will print out this. It will go to the next statement that follows while loop. All right? Is there any question? So this one won't be executed if A is 0, because when A is 0, it will break out the loop, the while loop, right away without executing this statement right here. Is there any question? However, if we do this, we still have a problem. When we input 33, 21, it's 3, alright? But if we run it again and input 21, 33, you'll see it's telling you that's 0. Because this time, when A is 0, we break out the loop. And then B will be the greatest common denominator instead of A. So what do? It's not certainly A. When B is 0, A is the answer. When A is 0, B is the answer. So what do? Do we print out A or print out B? What do? There's a smart way of doing this. You can just go ahead and print out A plus B, because either one of them, there should be one of them is 0. One of them should be 0. Okay? And so you just add them all together, and then this will be the greatest common denominator. And then if you have this one, this will be solve the problem very efficiently. Let's try it. See, we get 100 out of it. Alright? So, however, there's a way to make it faster. You don't really need this if statement at all. The only thing you are trying to do is, each time we always divide A by B. And after that, we don't divide B by A. We don't do that. We simply exchange the value of the two. AB is equal to BA. See, we just try to swap the value of the two variables AB. And this will do. And this time, it will always be B who's the 0 when it's executing, when it exiting the loop. And so when B is 0, A is the answer. See? Isn't that easier? Also, we can even make it even shorter. Alright? This one here, A divided by B, we can do it right here. A divided by B. We just go ahead and do it right here. And then assign this A divided by B to B. And we can even save this one right there. And this is the answer. This is actually the answer. A shorter answer to the problem. Then you can try it, save it, and evaluate it. You can see we still get the 100 out of that. So this is the Euclidean. This is the Euclidean algorithm that can solve the problem of greatest common denominator very efficiently. Alright? Is there any question? Alright. If you don't have any question, since it's already 3:17, I will let you practice a little and then we'll come back at 3:27.